Hey, this is OXDF, and today we're doing day 16 of the 2022 Hackvent challenge called Needle in a QR Stack. And they gave me this downloadable QR code, or image, I guess. And this image is giant. It's 8.5 megs. It will crash the standard viewer on Ubuntu, on Paint on Windows. But there are, I've got it open in GIMP here. You can take a look at it. It's a giant QR code with little QR codes all throughout it. And so every black pixel is actually either another QR code or, divided up into four. Here's more QR codes, or this one's divided up into four again, more QR codes, four again, and then all these again. Like it gets really small down to this level. So the challenge is, how do we read all these QR codes and find the flag, right? I'm going to pop open a VS Code here, and I've got my image right here in the folder. We will touch solve.py, open that up. We can say user bin env python 3. So we're going to import from PIL, import image. We're also going to need the import pyzbar as pyzbar. That's just how they recommend it in their docs. So with that, we can now, first thing we need to do is import the image, right? So we'll say im equals image dot haystack dot png. And next, I really want to crop it down. Now, if I just pass this to pyzbar, it's actually pretty good. It'll find the QR code with the border, but I'm going to want to start chunking this up into dividing it up into chunks. And so I really want to get rid of this big white border here. And so we're going to look here, we're going to zoom in on this very top corner, and we're going to see, if you look down right at this bottom, off this, just off the bottom of the picture, you can see it shows where the pixel XY positions of my cursor are. And so if we come right here to the corner, we can see it's 2400 to 2400. And then we'll go to the bottom and over. Hopefully we don't go too far. There we go. Let's zoom out a little bit. All right, and we can zoom in here. We can see this is 22,400. So we had 2,400 and 20,000, 2,400, 22,400. So we'll go back here and we're going to crop that. So we'll do im equals im.crop, and we just pass it the top and left, and then 22,400, I believe it was 22,400, like that. So now we have our image cropped down with all the white border removed. The next thing I'm going to do is I want to get a QR code out of it. See, the QR, actually the top level QR code doesn't read. I don't think that's, I couldn't get it to read with anything. So we're not going to stress about that, but we're going to make a function called like get QRs. We'll pass it the image, and we'll start with just that. We're going to add to that later, but we'll do def get QRs image, and then what are we going to do? So we're going to say codes equals pyzbar.decode, and then we're going to pass it the image. And I think that's all we need. So we can then say for code in codes, print code. Simple enough. Let's try it. Python solve.py. Module object is not callable on line 12. It's actually image.open. That'll help us. And so we get an error right away. And if we look at this error at the very bottom, it's saying PIL image decompression bomb error. Image size blah exceeds the limit of this. Could be an image bomb attack. And if we take this, get a copy of this and pull up window of Chrome over here, and we Google for this, we'll get this error right here. And someone shows us the answer right here is to set the image max pixels to whatever you need it to be, bigger than that. And so we will do that. So if we come up here, we can say, we already imported image. So we'll say image.max image pixels equals, and then we'll grab this number. And, for good measure, we can increase it, make it a little bigger just to be sure. And we can run this again, and we don't get that error, which is nice. Taking a minute to load in, but okay. So it's now getting this error here. And again, another error that I don't quite know what's going on. So we can grab this. It's interesting that it's taking so long. I think it has to do with the fact that it's just a lot of memory to manage. Loading this image and then unloading it. So we get this image here and we get, let's see. So these, if we scroll around, there's a good one here. Probably should have found this ahead of time, but we can cheat a little. Well, I'll say, so there's an answer I will have to find that I found, which is it's trying pyzbar is trying all sorts of different codes to read, or different barcode formats. And so if we say symbols, we say pyzbar dot zbar, not config, symbol dot q. So these are all, you can see here, when I hit dot, these are all the different things it knows how to do. And so we want QR code right there. So now we're only going to try that one. And so now when we run this, if we save first, it won't give us any errors. It actually doesn't find any code, so it's not that interesting, but we'll get there, right? So while this runs, we can start working on the next bit. So what we want to do now is actually divide this up. And so we're going to say, put 25 here, and we'll say like div by. So now what we're going to do is we're going to divide this into 25. And so we're going to say width, comma, h height equals im.size. And at the beginning, we know that, but we're going to, again, because we're going to do this kind of recursively, we need to work this through. So now we can say like small width, comma, small height equals width divided by div by, comma, height divided by div by, like that. So now we're going to get the new smaller width and height. And now we can say for y in range 0, comma, width, comma, and then the step is going to be the small width, like that. So then we can say for x in range 0, oops, I really should try 0, comma, actually, this is not width, this would be height. Doesn't matter because they're the same, it's a square, but let's just be, and then this will be small width, and this will be small height. Again, they're actually going to be the same, but so now we do for each x and y we move through, we'll say square equals img.crop, and that's going to go x, y, x plus small width, x plus y plus small height. I could have picked better variable names, but basically we're going to get our new square, and then we can say, let's get our codes here, and then we're not going to pass in image, we're going to pass in square. And then if there's codes in there, we will print them, and we will try this. So we're going to call it by 25. Why did I pick 25? Let's go back here into GIMP and take a look. We can see, if we look here, zoom way out. Ooh, I didn't need to drag this around. Let's move here. That this is actually divided. So if we think of these as like the biggest, this is the next biggest right here. So this right there is the next biggest QR code. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Color right there and move up. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So this is a grid of 25 of those. So we're going to divide by 25 and check all of those. And so if we run that again, we get a bunch of, so instead of printing code, let's actually print code.data. Let's see. It'll be a little easier to read. And we're getting a ton of, sorry, no flag here. Now it's interesting. Each of these QR codes is actually returning um, multiple data, which is interesting. We could also probably speed this up and try, for example, just instead of doing for code and codes, do print codes sub0 dot data, like that. But sometimes it's not going to find it. So I mean, it's actually easier just to do. We'll leave it as this and know that it can do that. What we don't want is sorry no flag here. So we'll do if code.data equals bytes sorry no flag here. I guess we should say not equal. We can print it. So now we run it. And we run for a second, again, because it takes a while to load all this image up. We should get relatively close to nothing. Okay, we did. So let's look at the picture again. If we go down to one of these blocks, let's find one block here. What's a good block to look at? These blocks are, so here's a block right here. Let's see. So can I draw it? This is the block. So within this block, we are going to divide the block into 4, or we'll divide the width and the height each in half. And that'll be this one right here. We'll then do that again to get, that's this one right here. That's two halves. Then we have one right here. I guess actually it's this right here where we divide that again. So it's 3 halves. Here's our 4 halves right here. This one right here. And then 5 halves actually down to these littlest ones. So we're going to do this 5 times. So what we want to do is make this into an array we can pass in. Where we do that and we do 2, 3, 4, 5. And so the way I'm going to interpret this is I'm going to come up here and divide by. Now I'm going to call this like divide by array. Oops. And I can say div by equals div by array 0. And then I can come down here and say, what do I call this function? Get QRs. And I'm going to pass in, I'm going to pass in my square. And I am going to also pass in div by array. But I'm not going to pass in the first one because I already did that one. So I'll do like 1 comma like that. Now recursively, I'm going to go diving deep in. I'm going to divide it by 25, and for each of those, I'm going to pass that square in and divide it by 2, and for each of those divide by 2, and for each of those divide by 2, and see if I get anything out. So let's try this again. We get a list index out of range. Let's see. We should do a check here. If len div by array is greater than 1, then we'll call this. That'll get us pretty quickly. And this is going to solve, hopefully. I'll probably pause this and speed through the running. Actually, I'm going to kill this real quick, and I'm going to run it with time so we can see how long passes. Okay, so we can see we got a flag here. Now we actually don't exit when we're done here. There's a couple little improvements we could make. For one, we'll let this run all the way through just to see it. We can say, we could also do img.save and call it like flag.png. And that way we get a copy of the QR code that actually solved it. That'd be kind of neat to see. We'll let this run through. I have let it run through. There's only one that matches. So we could also come up here and do import sys and I'll exit on finding it. That way we save ourselves some time. The other thing that's kind of interesting would be to get some stats about like how many QR codes we run into. And so one thing we could do is see how many squares we look at. I guess there's a question of how many squares we look at and how many codes we pull. I think what's happening with the codes is when I pull a square that's got like a bunch of little QR codes in it, it's actually good enough to find different QR codes in there and run them all. One thing that might be interesting to look at is doing this part first. So probably not before we cut the square, but so that we go recursively down and do the smallest ones first, because I think that's probably closer to where we're going to find the flag. Um, and but alternatively, we could also look at maybe even cutting off some of these, because we don't need, if I have a QR code with four cute little QR codes in it, it probably just finds all the codes. Um, so, but the fact that it only finds it once maybe means that's not the case. So, one other thing we could look at is if we want to do a count. So we could do like, let's see, count img count codes equals 0, 0. And we can come up here and say global count img count codes. And so every time we make a square, we can say count img plus equals 1. And every time we see a code, we can do count codes plus equals 1. So we did finish by running, by the way, in about 1 minute and 16 seconds. We can run this. We can actually say print f, let's do an f string, count img equals new line count codes equals, like that. And then just for entertainment value, we can do that same thing here. So what we've done now is we've set some global variables that are going to track the number of images we actually process here, and then the number of codes discovered. And we'll print it out when we find the flag, and we'll print it out at the end. So we'll give that a run. I'll speed through that for the video. All right, so we got our statistics here. It looks like we in finding the flag, we found the flag in the 437,000th image we looked at, and we pulled out 6,000, almost 7,000 codes at that point. And then we looked at, 80 in total by the end. So this is where we found the flag. And then at the end, we printed again. We found, in total, we looked at 853,125 different images, and we count 14,443 codes. If we look at this 800,520, look at that number. We can actually figure out what that is. And that is 1 plus, then the next grid we did 25 times 25, right? So we have that. Then we have 25 squared times 4. And now we're going to do that. Remember, we did this 5 times. So we'll do this times 4 plus this times 4 times 4 plus this times 4 times 4 times 4 plus this whole thing again times 4 times 4 times 4. And oops, did I miss one? Oh, I missed a 4. Hold on, times 4. And look at that. It comes out to 853,126. So we're off by 1 there, but because I bet we didn't count the initial one in our count here. So you can see that is just basically because we stepped through all those. Now we have a lot more images than we do codes, because there's a lot of spaces in there where it's just white, no codes are red. And there's a lot of them. The vast majority of them return no codes. So anyway, interesting statistics, I guess. I'm going to call it here. Thanks for hanging with me today, and I'll talk next time. Bye. So I actually ran this backwards, and image count image actually the number of codes looked at, and count codes is the number of images looked at. But it looks like we look at about 14,500 images, and we find almost 850,000 codes, and it's about halfway through that we find, yeah, about exactly halfway through that we find the flag. So I'm gonna fix that for the post, but I'm not gonna bother rerunning it for this video. Thanks for hanging out with me today. I will talk to you next time.